Hello everybody, my name is Mauricio Rodriguez and I am going to present the work entitled Fuzzy-Based Energy Management System for Isolated Microgrids using Generation and Demand Forecasting. These are the topics to be discussed in this presentation. I am going to present a quick introduction focused on microgrids, its sizing, and the proposed case studies. Next, I will talk about the energy management system for the microgrid together with the control design. Then I will present some simulation results, and finally I will summarize the main conclusions of this study. As a result of technological advances in electric power generation, different studies have indicated that soon there will be several isolated microgrids operating very close to each other. Therefore, it is crucial to provide new energy management strategies that are more efficient and easier to implement. So, these were proposed fuzzy-based energy management system for a single isolated microgrid that can be extended to isolated multiple microgrid systems. The microgrid comprises a photovoltaic array, a lead-acid battery bank, and a diesel generator. The three scenarios focus on providing different solutions for electricity supply. So, the first scenario considers only the diesel generator, the second scenario adds the array of PV panels, and the third scenario includes a lead-acid battery bank, which is handled by an energy management system. The proposed energy management system is based on a previous work, but modified for an isolated microgrid using this new decision block and a new output for the fuzzy logic controller. The control strategy includes a central moving average filter that estimates the average net power of the microgrid using the previous and the forecast 2 hours of the microgrid's net power. Likewise, the filter 2H blocks obtain the average value of the previous 2 hours from both the forecast error and the battery state of charge. Also, the shock estimator block estimates the current value of the battery state of charge depending on the battery power variation. So, according to the microgrid output profile Pout, the decision block allows the interaction of the energy management strategy with the diesel generator and the battery energy storage system, considering the following. If Pout is positive, the microgrid is presenting a power deficit. Therefore, the diesel generator should start whenever the technical minimum is exceeded. Otherwise, the battery must deliver the remainder demand power. Conversely, if Pout is negative, the microgrid presents a surplus power that will be stored in the energy storage system. The objective of the fuzzy logic controller is to modify the Pout profile to keep the battery state of charge oscillating as close as possible to 75% while permanently supplying the load. Also, the negative and positive variation range for both inputs and outputs provide better control to charge the battery and take power from the battery or diesel generator. On the one hand, the results above shows that the third scenario reduces by 50.32% and 5.12% the cost of diesel consumption compared to the first and second scenarios respectively. Also, the wasted diesel power is reduced entirely. On the other hand, the proposed energy management system using forecast reduces almost entirely the number of times the state of charge reaches its maximum and minimum limits compared to a strategy without forecast. Consequently, the proposed energy management system helps to improve the battery system lifetime. This is a comparison between the proposed energy management system using forecast versus a strategy without forecast. In the following hours from the breaking point 8, it can be observed that the net power will be negative, which means that there will be a higher PV generation than the load demand. So, the energy management system without forecast uses this excess power to increase the state of charge, which causes it to almost reach its maximum limit. In contrast, the proposed energy management system predicts this excess PV power, so it avoids the overcharging of the battery state of charge. Although all the scenarios ensure that the demand supply, the third scenario has improved performance using the proposed energy management system since it maintains the average state of charge value at 75%, increasing the energy storage system lifetime. In addition, the use of generation and demand forecasting improved the system, reducing by 5.08% the number of times the shock reaches the safe limits, compared to a strategy without forecast. As a future research, this work is expected to be the baseline for further studies in a new management strategy for power exchange to isolated multiple microgrid systems. Thank you very much for your attention. If you have any questions, don't hesitate to contact me.